Welcome back to the Garden with Joe and Holly radio show. Thank you for being with us today. Holly, let's go to the hotline and bring in our guest for this week.
John Libbs is the CEO and co-founder of Phyllom Bioproducts and has a background in biological science. Welcome to the program, John.
Yeah, thank you, Holly. Appreciate it.
Thank you, John, for being with us on the program. Just so we have clear transparency, the Phyllom Bioproducts is a sponsor of the program. You heard it just before the break. They've been with us. This is their 5th year sponsoring the program, so we greatly appreciate the support there. And I want to start out with, why are these pests, these beetles, these grubs, and these borers so hard to target specifically? What's unique about them, unlike other insects that are out there?
Well, this group of insects isn't necessarily any more difficult to target specifically. By targeting, meaning you develop a type of insecticide that will only work or perform, or let's be honest, kill a certain pest, insect, and not necessarily other insects which are beneficials, maybe such as ladybugs, bees, butterflies, or even develop products or insecticides that are not toxic to other types of organisms like fish, birds, people, your pets. So it's not as though these insects are specifically difficult. It's just it's a difficult process. And most of the chemicals, the reason they're more toxic is they're more broadly toxic. That they basically, kind of simple sciences, the molecules that work against the insects, they need to bind something in the insects, such as like imidacloprid, which has been a very popular chemical for a couple decades, was really the leader out there. It bound, basically neurons. And it didn't only bind neurons in insects, but also every other organism walking around or swimming around, including people. So that's why it's toxic. It would bind different tissues, neurons specifically in people, as well as these insects that it would kill. Then less toxic chemicals. The new darling in the market is acelepryn on the pro channel side, and it's Grubex on the retail side. It has a bit narrower spectrum of activity. It binds the chemical active, binds a little bit less broadly out there, but it still binds muscle receptors called rhyodine receptors in insects and stops molting, and that's the insects molting, and that's how it kills insects there. But people and animals, pets, birds, they have rhyodine receptors in their muscles, like your heart muscle. And so even a safer chemical still binds more broadly than, let's say, some of the biologicals like our product. So, so to develop a biological like ours or non-chemical, it's a very laborious process. So there's 2 ways you could do it. You could do a pretty deep screening, like for BT-based products or bacillus-based products. Typically, you go out in the environment and you dig up soil samples, or you get samples out of dead insects, and you go into the lab and you tease out of those samples different biological organisms. And if you hit on a type of bacterium called bacillus, genus of bacteria that's growing in a dead beetle, let's say, then you try to isolate that and you start testing it to see if it is indeed active against a beetle. And what happens with these sorts of biologicals, they are much more specific. Like you'll not find the same bacterium in maybe a dead ant that caused the ant to perish that you would in a beetle, let's say. And the other, and that's more of a natural biological, that you're going out there and you're digging up a bunch of samples, or you're looking for a bunch of samples, and you're doing a huge screening process of thousands and thousands of samples to try to figure out what's in the secret sauce of that particular natural sample that you dug up, let's say, try to figure out what killed the insect. Then there's genetic engineering that you can use, and that it's more eloquent science, and folks are trying to develop kind of more non-chemical, more genetically engineered products out there that would be insecticides, and they look for let's say parts of an insect that are really specific to an insect and not to mammals or other animals, and target that specific part of, let's say, the DNA to try to develop a kind of more of a non-chemical, genetically engineered product. But, again, that's not a natural product. It's probably, if they do the science right, will be a lot more specific than developing a chemistry or a chemical product in the lab. So it no matter what target pest you're going after, it's sort of the same process, and it's very laborious any way you go. But the bottom line is, like our product or our active ingredient, it's very targeted. We set out to find something that would work against beetles that was out in the environment. We actually found this in a dead beetle, this particular bacterium, and we had a bunch of different samples to screen, and this one became the lead. And then you have to better understand the bacterium. You have to understand what's in the bacterium that killed the insects, and that involves molecular biology, microbiology, protein chemistry, and you drill down on that, and we understood the protein, and we were experts in BTs and the cry proteins that are the insecticidal proteins, natural proteins in these types of products. So we knew what we were doing, and then we got a little bit lucky.
So tell us more about the Phyllom Bioproducts and what makes them unique, more specifically.
Yeah, so what really does make it unique is this particular protein active ingredient. We call it BTG, capital BTG. It really does specifically target scarab beetles, in particular. That includes grubs, and it binds a receptor in the gut of the target pest. So it'll bind this receptor, which is another protein. So you got a protein binding a protein, and it causes a pore in the insect gut, and it's like an ulcer. And what happens is the bug stops feeding, and then the guts kind of spill out, and the rest of the insect spills into the gut, and it eventually dies. And it works really, really well. There's a lot of strong binding there for biochemical reasons, strong binding. And then for the adult, what really makes it special, this particular BT and natural protein, is that it actually binds a second receptor in the adult target pest. So like adult Japanese beetle or adult emerald ash borer, and there's borers that are beetles, or even annual bluegrass weevil, which is a turf pest, and it works against the larvae and the adults there. The protein binds a second receptor that pops up in these adult beetles, and that's very, very rare for a BT-based protein. That's why ours is really the only one that has real good adulticide activity that you can count on out there in the market.
Well, is there a better time to switch to an organic or a non-chemical product for people who are like, well, when is it more like, when is the best time to plant a tree, either today or 10 years ago? Should you switch right away, or is there things to be considering?
Yeah, it's kind of a case-by-case basis. I mean, people are trying hard to develop non-chemicals. It's a tough deal. So it's sort of a case-by-case. I mean, our type of technology is registered, obviously, and by that you go through EPA, and you do a lot of tox studies. So you know the product in the tox profile, whether it actually kills bees or other pollinators, or is toxic to birds or fish, or all of that. So you go through that process, but you also go through a process where you turn in performance data, like field trial data and bioassay data, into the EPA. And so it's a deep dive review. It's almost like, let's say, registering a drug where you got to prove the performance and the lack of toxicity. And so, there's a lot of products out there that are kind of retread where they don't have to go through that process. They're not registered and they're not under the guidance of EPA or USDA. And I've seen a couple oils come out on the market for grub control lately. One's Jonathan Green, and I think there's Truly Organic branding. And I mean, they're oils. They're not going to work that well. They don't have to go through the EPA and prove they work. It's sort of testimonial. You probably get a little control, and I'd say, a lot of these products out there, they're non-chemical. You're probably killing maybe 2 out of 10, 3 out of 10 bugs that you're targeting at best. It's not like our products or the chemicals, which, I mean, you're counting on 8 out of 10 or 8 or 9 out of 10 or more. So it's pretty much low level performance, and there's really no review or much accountability, but it's kind of a sweet deal for some of these non-chemical products that are not registered, because they can kind of put a lot of marketing statements out there, but they don't have to prove anything, right? So there's a lot of that out there. I kind of call the oils snake oils. I'm sure there's a few people that use them. Neem oil people spray for flying insects, and it doesn't really target. It just gums up the mouth parts of the insect, so the insect can't eat. And unfortunately, with like a neem oil, like bonide cells, it works against butterflies and bees the same way it does any other insects. So they really aren't that targeted, some of these products. And it's just, it's a tough deal finding active ingredients that are non-chemicals that work. That's sort of the bottom line. But hey, if anybody out there sees an anthill with a bunch of dead ants laying around and they know it wasn't sprayed with a chemical, hey, gather up those ants and take them to a lab and try to figure out what killed them.
Well, your product, Phyllom Bioproducts, it's designed for the beetles, grubs, and borers, but it doesn't affect the beneficial insects. These companies that do not or are not able to prove that, and their chemical does affect those beneficial insects, do they not care, or is it more of a, well, this is where we're at, we'll take your money, you just be careful, and since you're using it, you're responsible now?
Well, it's a little bit of that. I think, the responsible brands will say, hey, it's a lot of it's about point of contact as well. So, like let's say a neem oil, don't spray it when the bees are foraging out there. So don't use it early morning, late at night when the bees are out there foraging. Don't spray directly on the bees. And, maybe you won't have point of contact with other beneficial insects. So there's other elements to this where you can even use, a chemical or maybe, a more broad spectrum biological non-chemical and still kind of minimize the risk to the, let's say, insects out there that you do not want to kill. But yeah, it's, you just got to be careful, I guess.
Right. Well, John, we greatly appreciate the time you've offered us. How can people find more information about the Phyllom Bioproducts? And if they have questions, how can they reach you?
Oh, sure. Yeah. So you can, if you'd like to order product, we have a website up called beetlegone.com, and that's Beetlegone with an E at the end. So BEETLEGONE.com. You can order a product there. You can go to our website for more information. We have more background information and data there. So you can learn a little more about the company. That's at PhyllomBioproducts.com, PhyLLOM as in Mary, bioproducts.com. And, you can hit info at Phyllom there, or I pick up the line and talk with customers all the time. My number is 650-296-2574. And give me a call.
Well, John, thank you so much. 1, for being a sponsor of the program, and 2, for doing the work and protecting the beneficial insects out there and caring about them, unlike maybe some other companies don't.
Hey, you bet. We'll keep looking for more good biologicals. We're always looking around there to help customers out and take care of their needs. More with a targeted approach and more safely for everything else. So
absolutely.
Yeah, I appreciate the time, Joey, Holly.
Absolutely.
Thank you very much.
Thank you very much.